What if telescopes are not only looking at the universe, but also looking through our own ruler and clock without realizing it? In the energy filament theory, the observations can be right while the interpretation drifts, because almost every objective number we quote is a ratio measured against local standards that may slowly evolve with the energy sea. Last episode we said redshift does not have to be a speedometer for a universe sprinting away. This episode pushes the knife deeper. Frequency, brightness, distance, even temperature, all look like hard facts. But they are all expressed as something out there compared to how we count things here. And here is not a neutral reference point. It is a physical machine made of local matter, local clocks, local definitions, and local assumptions. Start with frequency. When you say, "We measured the frequency of this light," what you really mean is, how many oscillations fit into 1 second. But who defines 1 second? Your atomic clock does. And what is an atomic clock? It is electrons and atoms cycling in a specific environment, under a specific gravitational field, inside a specific local tension state of the medium. So before you even talk about the sky, you've already translated time into our local beat. You can picture it like measuring a song's tempo with a metronome. If your metronome is perfectly stable, the tempo you report is a clean fact. But if the metronome's spring slowly changes stiffness with temperature, then your tempo measurement quietly inherits the spring's behavior. Now brightness. When you say, "This galaxy has this luminosity," you usually mean an energy flow, how much energy arrives per second per unit area. But, per second is your clock again, per unit area is your ruler again. Your detector turns incoming photons into numbers using local calibration, local electronics, local units. That is fine. It is how science works. The warning is not that the measurement is fake. The warning is that measurement is always measurement relative to a reference system. And if the reference system itself is physical and not guaranteed eternal, then the numbers can carry an extra layer, the behavior of the reference. Distance is even more dependent on the reference story. You do not stretch a tape measuring across billions of light years. You infer distance either from angular size using an assumed standard ruler, or from brightness using an assumed standard candle. And what does standards really mean? It means you are assuming the underlying physics of the object is known and stable enough to serve as a yardstick. Hidden behind those two words is a whole stack of priors about stellar structures, atomic transitions, gravity, and the cosmological model that maps redshifts into geometry. So in practice, cosmology often works like this. The universe sends us rhythms and energy. We feed them into a black box of local standards. That box is built from our present-day constants, our present-day time unit, our present-day length unit, and our present-day calibration pipeline. It outputs numbers. Then we build a cosmic story from those numbers. If the black box is truly rigid for billions of years, the story can be safely read as the universe itself. But if even a small part of the black box can drift, then the story includes a layer of us. Here is the simplest reason this is not a crazy thought. Atomic clocks already proved that internal rhythm is environment sensitive. Put the same kind of clock at different heights in Earth's gravitational field, and the tick rate shifts measurably. The clock truly runs differently. That means the internal oscillation periods of matter are not stamped by God onto a timeless stone tablet. They can respond to the environment. Mainstream physics interprets this through relativity, and that's fine. The deeper lesson still stands. What you call a time unit is tied to physical processes in matter. In this picture, the energy sea is the deeper environment. If the sea's tension slowly relaxes over cosmic time, and if matter's stable patterns are self-consistent structures inside that sea, then it is at least plausible that the rhythm of clocks, the spacing of energy levels, and the efficiency of propagation can drift together. If that happens, the telescope is not seeing wrong. It is seeing correctly through today's translation language. But then redshift, brightness, and derived distance are not direct copies of the universe's raw blueprint. They are redrawings made with today's pen. The punchline is simple. The data can be corrected while the ruler can be evolving. That is why two people can share the same sky and tell two different cosmic stories. One story assumes the ruler is rigid and the stage stretches. The other story allows the ruler to breathe with the medium and reads redshifts as a rhythm record. Next episodes build on this foundation. If the ruler itself can evolve, what parts of the standard narrative are truly observed? And what parts are translations that we have mistaken for reality itself? Tap follow, share it on New Physics, Clear Universe.